Hello, you're welcome. All right, so the topic is integration. So, what is integration? Now, the integration is the opposite. Okay, integration is the opposite of differentiation. Opposite of differentiation. All right, now, uh, let me explain this. All right, you know very well that if you are given a function, let's say a function y equal to f of x, all right, to differentiate. Once you differentiate this function, of course, what you have is written as dy dx. That is the derivative of y with respect to x. So what you have is another function. This was the original function, okay? After you perform the derivative of this function with respect to y, you have another function. Now the question is, how do you return back to the original function? How do I return back from this derivative to the original function? That is where integration actually comes in. Okay, so to return back to the original function, we apply integration. That is why integration is defined as the opposite of differentiation. So let's see how that is done. So for me to return back to the original function, for me to get back, for me to have my y, of course this y right here, from the derivative of y with respect to x. So y now will definitely is going to be the integral value of the derivative of x, f prime of x, then with respect to x. So this symbol right here, let me write it well. This symbol is the symbol of integration. Okay. So anytime you see this symbol, this is the symbol of integration. It's pronounced as the integral value. Integral value of the function f prime of x, of course, with respect to x. So the same way we actually differentiate a variable, a particular variable with respect to another variable, the same is applicable to integration. So that simply means that, okay, in a case where the function is actually or has different variable, please pardon me. So in a case where the function has different variable, let's say y is a function of t, f of t. So in this case, the integration is going to be, okay, f of t. Since the variable here, the independent variable is t, so I'm going to integrate with respect to t. All right. So this is integral value of f of t with respect to t. So please take note of that. So let's look at the different types of integration. Two different types of integration. Okay, so we have number one. This type is, of course, is the definite integral. Definite integrals. Then number two is we have the indefinite. The indefinite integrals. So what is the difference between these two? All right. So for definite integral, we integrate within a boundary or limit. So we are not integrating indefinitely within a boundary or limit. So anytime you see integration with, okay, that is within a boundary, okay, integral value from a to b, from the region between the limit of a to b of a function of x with respect to x. This is what is referred to as definite integral. Anytime you perform definite integral, you will end up having a constant value. It's going to end up giving a number, all right? Okay, though if actually the limit are constant. If the limit is constant, because after integrating, you have to insert the value of the limit into the integration. Okay. But the indefinites, we are not integrating within a boundary. So the only difference is this: there's no limit in indefinite integration. So you're only integrating function of x with respect to x. So I hope that is well understood. Okay. So we are performing in this video, we are starting with indefinite integrals. So I will go straight to the techniques of okay, or standard, and go straight to teaching you standard integrals. Okay, the same way we have standard derivative, I'm going to show you standard integrals. Okay, that will enable you. This is more like a formula of integration. All right, before we now look at the techniques of integration. Okay, let's start with a. When you are given the integral value of the power of x with respect to x. Now, integration is the opposite of differentiation. Remember, in differentiation, if I'm to differentiate x raised to power n, I will take the n behind, I'll take the n back. All right, then of course subtract the power by 1. But in this case, I will do the opposite. All right, so instead of taking n behind, I'm going to divide by n. So first of all, I'm going to, instead of subtracting 1 from the power of n, I'll add 1 to it. Then I'm not taking it back, I'll divide it by n plus 1. Then after integrating, all right, you have to add what constant c. This c is what is referred to as constant of integration. Every integration should have constant of integration. Now, how to find this constant, I'm going to show you when we start working on definite integral. All right, so for example, you are being given the integral value of x raised to the power of 2. Okay, with respect to x, simple. To integrate x, that's going to be x raised to the power 2 plus 1 divided by 2 plus 1. Okay, plus c, which is x raised to the power of 3 divided by 3, then of course plus c. All right, b. Okay, so let's look at the integral value of the power of x that has coefficient. In integration, coefficient always is a constant. It can go at the back of the integral value. A constant value will always go at the back so that you concentrate on the variable. All right, so of course you know how we do this. So the constant still remain while we integrate x raised to the power n, which is x raised to the power n plus 1 divided by n plus 1. Then of course don't forget to add the constant of integration. C. Okay. The integral value of a constant. Okay. Now remember, the integral value of a constant, derivative of a constant is always 0. But here, no, it's not 0. So all you just need to do, if you have a constant and you're asked to integrate, attach the variable of integration to that constant. So that's going to be ax plus c. Okay, let me give you a typical example. So if you are given 2dx to integrate, all right, 2dx is same as the integral value of 2dx is same as 2x plus c. All right, so what you're doing here is simply attaching the variable. All right, then d. Let's look at the integral value of the exponent of function. The exponent of a function will still be the same. Don't forget that. And the integral value of 1 all over, okay, function of 1 all over x. All right, so in this case, the integral value will be ln x plus c. For example, okay, let me just put it 1 over f of x. Let me put it this way: 1 over f of x. That's a linear function. Let me just, because f of x can be any function, let me just use x. Okay, in as much as what you have is a linear function. Okay, for example, okay, let's say you are being asked to evaluate the integral value of x, 1 over x plus 2 with respect to x. So this is simply ln x plus 2 plus c. Okay. Next, there's a lot, but I'm just giving you some few. Let's go to trigonometry. So this part has to do with trigonometry. All right. The integral value of sine x with respect to x is equal to minus cos x, of course, plus c. The integral value of cos x with respect to x, this is going to be sin x. There's no minus in this case. Sin x plus c. I hope that is well understood. Okay, so I'm going to give you more of standard derivative, but let's look at the techniques. Okay, there won't be any relevance of getting to know all the standard derivative without knowing how to evaluate the standard integrals, without knowing how to evaluate the integrals of a function. So I'm going to show you different techniques. Okay, techniques of integration. Now, under these techniques, so we are going to look at polynomial function. Number 2, we are going to look at function of a linear function. Number 3, okay, we are going to look at integration by integration of the form. Okay, let me write it in full. Integration of the form that is the integral value of f prime of x all over f of x with respect to x. So that is an integration in which the numerator is the derivative of the denominator. We are going to see that. Okay. Number 4, we are going to look at integration by partial fraction. Number 5, we also consider integration by parts. There's a lot. There are more techniques of integration than derivative, but let's work on this one first. All right, starting with polynomials. Now, of course, you know what a polynomial is. Okay, so I'm going to illustrate this with an example. So this is just very simple. Okay, so if you are being given a polynomial, just integrate the different term of the polynomial, and you're good to go. Evaluate the following. A. Integral value of x squared plus 3x plus 5, all with respect to x. B. The integral value of 5x bracket x plus 2x plus 3 with respect to, okay, with respect to x. So this is simple. Solution. Starting with A. So I'm going to differentiate this individually. So this is the same as the integral value of x squared with respect to x plus the integral value of 3x with respect to x plus the integral value of 5 with respect to x. You can decide to separate it, or you can just go ahead to integrate individually. Of course, if we integrate this, this is going to be x raised to the power 3 divided by 3 plus, this is a constant, that will go 3x raised to the power 2 divided by 2. Then if we integrate 5, that is simply 5x plus the constant of integration. Okay, can leave it that way. Then B. So in the case of B, I will just simply expand this. So, okay, so I have to expand it. All right. Okay, let me clear this so that I will be seeing the question. All right, so here we go. So if I'm to expand this, I'm going to have the integral value of 5x cubed. Okay, please pardon me. This is square. Yes. Yeah. So this is 5x raised to the power 4, 5x cubed. Then of course, not 5x again. This 5 times 2 is 10. 10x cubed. 5 times 3. That is 15x squared. All with respect to x. Let's work on this. Of course, this is 5x raised to the power of 5. Add 1 to this, then of course divide by 5. The same thing happens here. Add 1 to the 3. 10x raised to the power 4, divide by 4. 15x raised to the power 3, divide by 3. Plus my constant of integration. Alright. So this is B. So, of course, this is going to be x raised to the power 5. 2 will go. Of course, 5x raised to the power 4 divided by 2. This is 5x raised to the power 3 plus C. Alright, so here we are. This is the final answer. Alright, it's simple. So for polynomial, just integrate the different terms of the polynomial individually. Okay, so we'll look at a function of a linear function. I will still illustrate with an example. Of course, you know what a function of a linear function is, okay? When you have y is equal to a function of x, a function of u. Y is a function of u, and u itself, u is a function of x. For example, if I give you 3x plus 1, this is a linear function, then it is being cubed. This is a function of a linear function. The linear function is 3x plus 1. Then the function of this linear function is the cube of the linear function. Alright, so can we illustrate with an example? Alright, let's do that. So the question goes this way. Evaluate the following. Alright, A, of course, is simple. I'll just use this question. 3x plus 1 raised to the power of 3 with respect to x. B, the integral value of the exponent of 5x plus 1 with respect to x. C, the integral value of the sine of 2x plus 1 with respect to x. C, the integral value of 1 all over 3x minus 2 with respect to x. Okay. Solution. Starting with the A part of the question. What is the linear function here? The linear function is 3x plus 1. So I use u to represent it. Let u be equal to the linear function, which is 3x plus 1. All I just need to do is to find the derivative of u with respect to x. If I differentiate u with respect to x, of course, if I differentiate 3x, I will have 3. If I differentiate 1, I will have 0. So now, since my u is equal to 3x plus 1, I can now rewrite the integral value. So this is the integral value of 3x plus 1, which of course is u. This is u. Okay, please pardon me. Look at the question. The integration is 3x plus 1 all cubed. So 3x plus 1 is already u. So this will be u cubed with respect to x. Now, as you can see, there's no way I can differentiate u with respect to x. It's not possible. So that is the reason I brought this derivative, so that I'll be able to replace the x with the u. So in this case now, if I make the x the subject of this expression, if I cross multiply, of course, if I cross multiply to make x the subject, the x will be equal to du all over 3. So this is going to be equal to the integral value of u with respect to 3. So I'm going to replace this dx by du all over 3. Of course, you know that in integration, the constant, in this case 3, will go to the back of the integral value. If I take it to the back, that will be 1 all over 3. Then the integral value of u cubed with respect to u. So we can now integrate. Integrating u cubed, you know what it's going to be. So this is going to be 1 all over 3 If I integrate u cubed, I'm going to have u raised to the power of 4, and of course divided by 4. So this is times. So this is going to be u raised to the power of 4 all over 3 times 4, which of course is 12. So having done that, now I can now return the value of u. Remember, u was 3x. Okay, u was 3x plus 1. So my final, don't forget to add plus c. Okay, so this is gonna be 3x plus 1 all raised to the power of 4 and divided by 12 plus c. I hope that is well understood. Okay, so let's work on B. B part of the question. I have the exponent of 5x plus 1. The integral value of exponent of 5x plus 1 with respect to x. If we go by this method, our linear function u is 5x plus 1. If we evaluate du ds, we'll have 5. So from here, if I make the ds the subject, that will be du all over 5. So this will now be the integral value of the exponent of the whole of this is u. Exponent of u. Then I have to replace this. The s is du all over 5. So of course, if I integrate exponent u, I'll still have exponent u. This is a constant, it still remains. Alright, then don't forget to add the constant of integration. So finally, this is going to be the this is equal to the exponent of 5x plus 1 all over 5, then of course plus c. All right, let's look at c, sine 2x plus 1. I'm very sure that you'll be able to do this. Okay. C, the integral value of sine 2x, sine bracket open 2x plus 1. With respect to x. So of course, as usual, let u be equal to 2x plus 1. So if I evaluate du with respect to x, I have 2. So from here, ds is going to be equal to du all over 2. Okay, so with what I have, so this is going to be the integral value of the sine of u, then with respect to du all over 2. If I integrate sine u, you know I have minus cos u. Okay, so divided by 2 plus the constant of integration, which of course is equal to minus cos 2x plus 1 all over 2 plus the constant of integration. All right. The last but not the least, 1 all over 3x minus 2. Okay, so number 4, right? So let u be equal to 3x minus 2. Du is going to be equal to, or rather ds. ds is going to be equal to du all over 3. And you know that the integral value of, this is going to be the integral value of 1 all over u okay, with respect to du all over 3. If I do this, 1 all over u, the integral value of 1 all over u is ln u. Okay? The integral value of this is ln u. Don't forget that we still have constant at the denominator divided by 3 plus c. So this is going to be ln 3x minus 2, of course, divided by 3. Okay. Then plus, okay, yeah, divided by 3 plus c. Okay, so that's just by the way. Okay, all this method of integration, this method of integration by, okay, applying function of a linear function, these are really long method. I'm going to show you a shorter way of doing this. As you can see, there's a pattern that is being developed in all this, in which you can develop a shortcut to all this integration, and I'm going to be showing you that in the next video. Okay, so see you in the next video. Thank you very much.